lost comm with the spacecraft.
If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
There's a little bit of drama because this is true exploration. New Horizons is flying into the unknown.
When we got there, we saw something that absolutely blew our minds. It was incredible. When we saw these photographs of what it actually looked like, really a world in its own right, it was mind-blowing. There was active geology on Pluto right now. Something so far from the sun should just be a cold, dead world, but it's not. It had this living, breathing heart.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft.
We've been using the best telescopes that we had available to us to observe it for years, most notably the Hubble Space Telescope. And through a lot of observations, a map was made of Pluto's brightness, but it was very fuzzy. You have some light periods, some dark bits, but that's all we had. The Voyager spacecrafts that explored the rest of the solar system didn't go past Pluto. We had to send a dedicated spacecraft to go and have a look at Pluto because we'd never seen it before. I mean, lots of people move their personal life around their work, and mine's no different, but it is different in the sense that, you know, the spacecraft goes past Pluto once in your lifetime. And so we arranged our wedding ahead of that, and then we actually decided to wait to have children until after Pluto. When you have a mission like Pluto, you have times where you really are quite busy on the mission. You're taking new data. We flew past Jupiter, that gives you data. We're looking at the stars to make sure our instruments are still operating and they're healthy. But there are periods whereby, you know, the spacecraft is in hibernation, it's spinning, it's not taking data. If there's a problem, it knows how to call us, but other than that, it's just marching forward towards Pluto.
We lost comm with the spacecraft. Totally silent. And so you can imagine when you're in any kind of critical situation, the worst thing is lack of any information. And that's essentially what we had.
Pluto Ace, Mom, on New Horizons Pluto 1. Could you advise why we are not locking up to telemetry?
About the 4th of July, so American Independence Day in 2015, it goes into safe mode. It just stops doing anything except pointing back to the Earth and telling us there's a problem.
Mom, Pluto Ace, stand by. I'll check with the station on the status of telemetry.
So to put that into context, our encounter is 10 days at this point out, and it's a flyby. We're going to go past Pluto once. We're not going to slow down. We're not going to stop. We're not entering the system. We're flying by it. If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
Station 43, Pluto Ace.
Mom, on New Horizons Pluto 1. Go ahead, Pluto Ace.
We found the spacecraft. It was responding to us. It was giving us information, but it was in a state that could not accomplish the encounter with Pluto.
It takes 9 hours to talk to the spacecraft at that point. And so we were doing the tests on the ground, making sure that the sequence that we were going to upload was working.
It took us 3 days to do that. Around the clock, we slept in our offices. No one wanted to leave because we had waited all this time, and there was no way that we were going to let this opportunity slip by.
And it will transmit a message back to the Earth for about 20 minutes, in which we'll find out how it's doing. But there's a little bit of drama because this is true exploration. New Horizons is flying into the unknown.
So before we entered the Pluto system, we downloaded the highest spatial resolution observations we'd made to date. So there's only 5 of us in the whole world that had seen this image of Pluto. Oh, my hair looks better like that. And we're all just sitting there at that moment of like, whoa.
We've recorded data of the Pluto system, and we're outbound for Pluto.
To see that was just incredible. It was a life-changing experience.
Look what we accomplished. It's truly amazing. Humankind can go out and explore these worlds. And to see Pluto be revealed just before our eyes.
So when you see an image of a new world, especially one as diverse as Pluto, there are so many things you can take home from it. And one of the first that jumped out of me is that heart-shaped region that's in the middle of the encounter hemisphere. And in particular on the left-hand side of the heart, it's very smooth. And you don't get smooth regions on any worlds unless there's some form of active reprocessing. And so there was active geology on Pluto right now. Couldn't believe it. Still can't really. So why is it so geologically active? We still don't have all the answers. Does Pluto have a subsurface ocean? There was mountains with holes in, which points to the idea of a volcano. Maybe it's a cryovolcano, a volcano that erupts ice. And that would be better explained if there was enough heating to sort of maintain a liquid water ocean. Pluto's really cold. Really, really, really cold, colder than you could possibly imagine cold. It's so cold that water there is sort of the bedrock. The ice is so hard it can form mountains, which is something that of course just couldn't occur on the Earth. And so on Pluto we see these big ice structures. So it all kind of implies that there's lots on Pluto that is quite fresh and new. And so whether you could have life that is in a sort of this contained place, subsurface, so dark, but with an energy source, it's hard to imagine from what we know of life. It's not impossible, but it's going to be a difficult thing to get to see because it's so far from the Earth. We don't want to do any harm. You certainly wouldn't want to send, a probe into this pristine world because you could kill everything that was in there just as you discover it. So it's definitely the thing of sci-fi, and it's fun to think about, but it's going to be a really difficult thing to test. Anyone that's been working at home during this lockdown will understand the frustration of limited broadband. And we have this on New Horizons because the spacecraft is so far from the Earth. Getting a signal back is so weak. It's meant that our 6 gigabytes of data that the spacecraft took during the encounter is still being downloaded. You're really trying to make sure you have everything on the ground before it gets wiped from the spacecraft, before it's gone from humanity forever. You want to make sure you have everything. True exploration isn't something that normal people get to do, right? I've got to explore worlds that have never been seen before. And I think once you've had that taste, it's just, you can't let it go. It's not quite adrenaline junkie stuff, but you want to do it again. And so it would be absolutely incredible to do it twice in a lifetime. What a privilege.
Jupiter played a crucial role in developing life on Earth. Thank you, Jupiter. We normally just see the very top layer of atmosphere. There are so many secrets of Jupiter contained below these clouds. So I'm currently analyzing data from the Juno spacecraft.
Juno, the spacecraft, has all these magical instruments to see inside of Jupiter. Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. This is one of the largest spacecraft ever made. We had to, build an armored tank to go there.
Jupiter's radiation environment is the most dangerous environment for a spacecraft to go into. It's a region we were very afraid of because no one had ever been there before.
If that doesn't fire just right, you fly right past Jupiter. That's it. You don't go into orbit, you go around the solar system again. By the time you come back to Jupiter, it's decades later.
Almost there.
It's a very uncomfortable situation.
Welcome to Jupiter.
We just did the hardest thing NASA's ever done.
What we actually found blew our minds. When you first look at Jupiter, what really catches your eye is the Great Red Spot. It's this gigantic storm in the southern hemisphere of Jupiter. It's larger than the Earth. It has been around for over 200 years, and it's absolutely incredible. Then you begin to look further away and you see these belts and zones moving in different directions on the planet, and everywhere you look, you basically see a storm. And what drives these storms? Well, likely Jupiter is collapsing very, very slowly. This is energy left from its formation, and this energy is released, and it's that energy that churns the atmosphere so violently all the time. This is in contrast to Earth, where our weather is governed by the sun. A lot of tourists go to northern Sweden and Scandinavia to see the northern lights of the Earth. If you really want to show and something that's on all the time, you go to Jupiter and see Jupiter's aurora. It's brighter than all the energy that all the power plants on Earth can produce, and is actually fueled by a volcano. So Jupiter has this moon called Io, and that's fiercely volcanic, spewing out material near Jupiter all the time, about a ton a second of material. This material gets trapped by the magnetic field as energy funnels down, impacting the planet, and that's the aurora we see.
What we find is vortices, kind of like hurricanes. They're all packed together, and we've been watching them now for a year, and they haven't all merged into one. They're packed in this pentagonal pattern. There's actually 6 of them if you count the one in the center. And they just sort of sit there. And this is remarkable. This is really the first time that anyone has seen such a geometric pattern of cyclones on any planet or anywhere. I look at an image like that and I say, wow. The idea that nature can make such a geometrical structure is fascinating.
We've known since the Voyager missions that lightning exists in the clouds of Jupiter. What Juno's found is there's a second form of lightning at Jupiter.
This is the signal from the microwave radiometer, and it's measuring the heat of the planet, and every now and then we get a spike. Bam! It became very clear very soon that this was radio signals from the lightning in Jupiter's atmosphere. Maybe 1,000 times brighter than the lightning on Earth.
The presence of lightning at Jupiter hints at vast amount of water, and Juno's actually confirmed that in the lower part of the atmosphere, 1 out of 400 molecules is a water molecule. That's a lot of water. Does that mean that there's life in Jupiter's atmosphere? Well, ultimately, we don't know. We have this notion of what life is based on our experience here on Earth. Can we translate that to Jupiter? Can there be life forms floating about in the atmosphere? We don't really know. Jupiter is so massive, about 300 times more heavy than the Earth. And with all this gravitational power comes huge responsibilities. Jupiter originally flung water into the inner solar system, creating the conditions for life at Earth. So thank you, Jupiter. It also likely altered the orbit of an asteroid that killed the dinosaurs 65 million years ago. Jupiter's presence, gravitational presence, is absolutely everywhere.
This is the outline of Jupiter, and basically what we're seeing there are just the cloud tops. But what we want to know is what's inside Jupiter.
Before Juno, we believed that Jupiter had a really small core onto which gas just stuck by gravitational forces. But what Juno has found is actually that Jupiter has got a really big core.
There's something denser. It's probably like 5-10 Earth masses. It's mostly made of rocks at very high pressures and temperatures. So that shows that Jupiter started its life as a rocky, icy world, and that it captured the gas that was around, the hydrogen and helium. And that formed a giant planet that's Jupiter now.
I first became interested in Jupiter when I was at college in Sweden. There was a telescope on the roof, and one night we got to see Jupiter with our own eyes, and it was absolutely extraordinary. A whole different world that I can see right there in the night sky. What would he think about me today? I think He'd be proud, ecstatic.
Is the signal real? If the signal is real, we still have to be able to explain what or who is making it. I've dedicated my entire career to finding life beyond our Earth, and lately I've been trying to find it on Venus, the planet next door.
Oh wow. Life on Venus. That just blew me away.
Venus is an absolute hell. The temperatures on the surface average about 470 Celsius, which is hot enough to melt lead. Air pressure on the surface is what it would feel like to be about a mile under the ocean. Because the clouds of sulfuric acid are so dense with haze, Venus became a desolate hellscape. The Veneer missions were an extraordinary program. Several of the Veneers didn't even attempt to land. One of them lasted 127 minutes and provided a lot of data. Some tried to take pictures, but the lens caps wouldn't come out, and by the time we got to 7, 8, 9, 10, 11, 12 Veneer missions, we had managed to get to the surface of Venus, take measurements and be sure of its intense temperatures and pressures, and also the hurricane-level winds that were passing in the atmosphere.
When they eventually got the correct sort of radar going through the clouds and seeing what was going on, and then it got really exciting. Then we thought, this is a planet with a lot of volcanoes on it, and even more fascinating, volcanoes unlike any we see on the Earth.
These volcanoes had been partly responsible for spewing out gases that led to Venus becoming the fiery hell it is now. But recent data shows there may still be life left in them yet.
They found that Venus had hotspots within it, something active on Venus. That really is quite exciting to actually see these.
We do know life is very resourceful, and there is one place on Venus that could host life. If there is alien life in the clouds of Venus or anywhere else beyond the Earth, we have very little hope of ever actually seeing them. But we can look for the gases that life produces, and that is what I've dedicated my entire career to do. My specialty is looking for a gas called phosphine. It was just here, you know? I was actually trying to find my phosphine molecule. Okay, well, we lost phosphine, which actually is very fitting. On Earth, phosphine, it's produced by life that doesn't care for oxygen. So I thought maybe we could find phosphine on other planets that are oxygen poor, and there it would be a very robust sign of life. An astronomer from Cardiff named Jane Greaves reached out to me saying,
oh wow, perhaps there really are these floating microbes.
They needed some help interpreting a potential signal from Venus obtained with the ALMA telescope that seemed to indicate there was a sign of phosphine in the clouds of Venus.
When you go really high up, so about 50 kilometers up, the pressure in the clouds is like it is at the surface of the Earth, and the temperature is actually like 20 or 30 centigrade, so it's really quite habitable.
Jane and the rest of our team used 2 telescopes, many months apart and in completely different parts of the world, to look at the atmosphere of Venus. And these 2 independent observations agreed with one another.
So that was January 2019 when I was reasonably sure, and that's June of 2019. I'm like, here it is again.
I at first did not believe it, but there was a small part of me that thought my whole career had been for something.
It's really obvious there's something there, so that kind of blew me away.
Maybe all the work I had done saying that phosphine was a sign of life was just going to pay out right now.
Astronomers have announced they found what could be evidence of life elsewhere, and not on Mars, but on the much more inhospitable Venus.
There's something seriously weird going on there. Perhaps this is life. And that just blew me away. It was so exciting.
So you can see that really they look very like each other. So it was a robust result. 2 telescopes, nothing to do with each other, saw the same thing.
My second instinct that kicked in quite quickly was, is the signal real? If it is it for sure phosphine, or could there be another molecule mimicking it? And if it is real and it is phosphine, Was I right in saying that only life could produce it?
Well, there are two ways that it could possibly be life. One is there's just a completely different biochemistry there. It's radically different from anything we imagine on Earth. The other way, that in principle, a more water-loving life, a bit more like the biochemistry you see on Earth, could hide itself away inside a protective shell of some sort, inside the sulfuric acid droplets.
There's questions on whether even the signal is real. If the signal is real, there are questions on whether it is phosphine or potentially other molecules that can mimic the same signal, like sulfur dioxide. If the signal is real and it is phosphine, we still have to be able to explain what or who is making it. And only then could we consider that we have found life. We're all just trying to figure out the truth. And I would love for there to be phosphine, but primarily I would love to know what's happening in the clouds of Venus, phosphine or no phosphine. And the rest of the community is doing the same thing.
Really hoping somebody will come in and say we could start to plan for a space mission. And fly through the atmosphere would be super exciting. And given they managed to get a lander to the surface and signals out in 1985, that's got to be possible, right?
We are only just now beginning to be able to even interpret the signals from places that could host life. It's a really exciting time to be discovering potentially the first one of those signs in the planet next door. But there will be many, many more to come.
It was really a wow moment. There was liquid water elsewhere in the solar system. We had been right. You have all of the ingredients that you need, that we know of, to develop life as we know it.
We have cleared the tower, and the Cassini spacecraft is on its way to Saturn.
So these sort of hard cases, these James Bond-looking cases, are used to transport the flight hardware. This is one of the magnetometer sensors that I worked on, and it will have been integrated onto the boom that came out from the side of the spacecraft.
And here's part of the magnetometer instrument, and here's the other half of the magnetometer instrument. This is a quarter-size model, so this is a quarter-size me. I'd like to be this weight, not this height.
She was one of the best things about the Cassini mission, because I spoke to her on the phone every couple of days for years and years and years. So a gas giant like Saturn is incredibly mysterious.
Saturn just captivates people because it looks so supernatural. It engenders the immediate feeling that it can't possibly be real.
It has no solid surface, and it has rings around it, and we don't necessarily know where those rings came from or how old they are.
These, as you can see, are spiky shadows that are created by these features here that are sticking up 2.5 miles.
Having the perspective of Cassini to be able to see that was one of the most extraordinary things, I think, about the images that came back.
It was just extraordinary. It was out of science fiction.
Some of the most amazing discoveries that Cassini made were about Saturn's moons. The first flyby of Enceladus was not terribly close, but something funny was happening in the magnetometer data.
Okay, so put it into slideshow.
My boss came to the team and said,
"You can see there's a little pimple in the data, just over there.
This looks intriguing. This is not what we expect. We expect on a rocky moon for the magnetic field to drape over it, a bit like a nice peaceful curtain draping over a window that's not moving. And instead it looks like there's some sort of breeze gently fluttering that curtain."
And what we were able to do is calculate what ions were generating those waves, and it was water group ions.
So Michelle decided, after discussions with all of us, that she would go to the Jet Propulsion Lab and she would propose moving the next flyby of Enceladus, which wasn't for some time to come, to much sooner. And this was a huge risk for her.
We knew for us to be able to have a chance of really seeing what was going on at Enceladus, we needed to get closer.
The principal investigator of the magnetometer, God bless her, she went into action and convinced the project to take the spacecraft close to the South Pole so we could all get a better look.
And I must confess, I didn't sleep for 2 or 3 nights before that close flyby, because if we hadn't seen anything, no one would ever have believed anything I said again. So, but what we found was spectacular.
This image made me nearly fall off my chair, because here we see dozens of jets, big and small, coming off the South Polar region.
It was fantastic. It was really a wow sort of a moment. There was liquid water elsewhere in the solar system other than the Earth. Enceladus, tiny rocky moon of Saturn, is geologically active. A stable liquid environment, organic material, and contact with rock, you have all of the ingredients that you need, that we know of, to develop life as we know it.
I love this picture, and it's about as much meaning as you can get out of the Cassini mission, because we know that that moon has an ocean in it that could harbor life.
One of the mysteries of Saturn originally was the source of the rings, and it turns out that Enceladus's geysers feed the very faint but very wide E-ring. It shouldn't be surprising that we found such interesting geological activity on a planet with 82 moons. Ironically, all these wonderful discoveries that we made meant you run out of fuel. It was on 1%, it had an empty tank, so we had to crash it into the planet and let it go.
This is the start of the end of the mission. We're running out of fuel, and we're going to make sure we go out with as much great science as we can.
We want to see how much of the atmosphere we can see before we lose the signal, before it can't fight the atmosphere anymore and it goes off point.
These last grand finale orbits where Cassini dove between the rings and the planet, they were never foreseen in the original mission planning. Actually getting to do that was really remarkable. Take these kind of dangerous dives between the rings and the planet to see what that space was like, actually with the spacecraft physically being there, was really remarkable.
In some ways, I just want it to be over now. You know, you're sort of waiting for it to end, and it's really weird.
Quite a lot of us were gathered round, tensely waiting for the data to come back. We were relying on the commands that we had written and we had sent to the spacecraft to have worked properly, and for the spacecraft to continue to be able to talk to us right up to the very last minute.
I can confirm science playback is unlocked.
And then it'll go away. We'll lose the signal, and that'll be end of mission.
Cross for 0 time.
So that would be the end of the spacecraft. Project manager off the net.
It doesn't feel a long way away, actually, because every time I watch it, I am immediately there again. So that I guess says something about the impact that the end of mission had.
That was a great spacecraft. It did exactly what we asked it to do, all the way to the end.
When you have checked on a spacecraft every day for more than a decade, and then suddenly it's not there, it really is a wrench. It's a blow, and you feel sadness and a certain amount of grief.
Godspeed. Think it and release it.
The question we all want to know is, are we alone? And now we have eyes on the ground. Perseverance is ready to answer that question for us.
Touchdown confirmed. Perseverance safely.
For the last 4 years, I've been recreating the surface of Mars in my lab at the University of Oxford. What I've most been interested in is whether I could recreate lakes and other liquid water environments that might have existed on the surface of Mars about 3.5 billion years ago. Where it gets really interesting is that now NASA has landed a rover, the Perseverance rover, right in a crater that might have once hosted a lake. Although there's no water on the surface of Mars today, there is inescapable evidence that it was once present. When you look at it from space, you'll see certain features that jump out at you as being quite similar to those we have on Earth. You'll see sweeping valleys that look like they were carved from liquid water.
These are actually pebbles that are a few centimeters in diameter. What you can see when you look at the pebble outlines is that they have rounded shapes. So they've been basically rounded during a transport process. And they're too large to have been moved and rounded by wind processes. And so the only way we can actually get this rounding is by water flow.
You'll see gigantic canyons. This one here is the Valles Marineris. And this thing would stretch from Los Angeles to New York. This thing is truly colossal.
And I remember when this image first came up and we were all huddled around a giant screen looking at this, it actually took us a while to really hit home. Oh gosh, actually this is the first evidence from on the ground of water flow on Mars.
We see great big ice caps at the poles, much like we do on Earth as well. We see signs from space that are immediately recognizable as great big channels, enormous floodplains, the largest in the solar system, that would have excoriated their way across plains as large as the continent of North America. We see chemical signatures, we see minerals that have water locked in their structures that could have only formed when that water was freely available. And we also see both of these coming together in the form of certain features that we know from studying them on Earth only form where there's bodies of water. Where Perseverance is sat is a crater called Jezero, and why Jezero crater was selected is that it combines these two key indicators of water in one site. And how deltas form is where you have a river flowing across the surface of a planet, and in its water it's containing all kinds of churned up sediments. And then as soon as that river reaches an open body of water, like a lake or an ocean, it dumps all of that sediment load. Why the Perseverance mission is so exciting to me is that for the past 4 years, it was those carbonates that are found in its delta that I was trying to recreate in my lab. Perseverance has been in the making for a very long time, and it's a roving scientific suite of instruments. It's a moving laboratory, and it's absolutely incredible the things it can do. So to finally get to hear the sounds of grains of sand being turned over, and the sounds of that very thin atmosphere being blustered around in this crater, it's absolutely incredible. The first times I saw the pictures from the surface, it was like being in Star Wars and learning about whole new places. I couldn't believe it, and here, 5-6 years later, I am with my PhD on the surface of Mars. I feel very, very fortunate.
Altimeter data confirm that Ingenuity has performed its first flight of a powered aircraft to another planet.
What's incredible about the little Ingenuity craft is that this is the first time anything has been airborne on another planet at all, not just Mars.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
The idea is that it might be able to scout ahead to places of interest for future astronauts and look for any hazards. Perseverance has 4 main scientific goals. First is to search for habitable conditions. The second is it's interested in searching for biosignatures. The third mission goal is to harvest and then cache together samples of interest to return to Earth. The absolute dream is to one day have a sample of Martian soil returned from Jezero crater from those carbonates that you can see from orbit and to compare that to the kinds of crystals that I was forming in my lab and just see how similar are they, what do they look like. And the final goal of the Perseverance mission is to prepare for humans to come and live there one day. People who are fit, people who are top in their fields, people who are experts, people who have a spirit of adventure. But I would say most critically, you need people who have the right temperament.
Think about a mission to Mars. What is it? Is it outdoor stuff or is it confinement? And then I see somebody that says, I have a stamp collection, I do a lot of reading, I enjoy watching movies, and I'm thinking, that might be good for confinement.
Artemis is a key step in getting humans to Mars. Right now, launching humans from Earth is extremely expensive because we're just so heavy getting off this gigantic rock. Instead, if we can have a base set up on the moon, we can have supplies ready to go from there, manufactured on the moon, that can then be launched straight to Mars. And so this makes it cheaper and easier to be launching things not just to Mars, but perhaps around the solar system as well. Once you've got to Mars, there are a whole host of problems that you wouldn't even think about based on life on Earth.
So you need something to protect you from essentially exploding, or at least having your skin all stretched out and the blood boiling and getting the bends, things like that. The way spacesuits are designed now, they're mostly pressurized spacecraft. Essentially, they're almost like a mini spaceship.
Things like, how do you maintain water? How do you recycle your water supply? How do you recycle waste?
Here we are at the throne. Number 2, right here. It's pretty small, so you have to have pretty good aim.
How do you keep making the best of everything you've got without throwing things away? And they're all problems that we're going to have to overcome if we're ever going to be a spacefaring interplanetary species. I've had a very long time to think about whether I would go to Mars, and so I'm not being flippant when I say yes, absolutely. Would absolutely love to go. It would be the most fabulous adventure. There'd be so much to do and explore and so many questions, endless questions. So yes, absolutely.